Hi everyone. Hi everyone. In this video, we will learn about topic function and derivative. Actually, this topic you already covered during school time and foundation, but here you will learn the extension of it. Okay, so let's look into the first subtopic for this section, which is function and derivative, where we learn about limit of a function. Okay, why we need to learn limit so limit are needed to define differential calculus. So every application is even in our daily life, a differential equation is always there, but then we didn't put it as a differential equation, but the scenario is actually more or less a differential equation. So we assume that the limit define the term in the equation so that the equation is exist. Okay, so limits are also needed in integral calculus because an integral is defined over a range of variable, and this form the limit in integration. So for example, putting it in a very layman term, I would say, in our daily life. Let's say where the limits coming in, let's say we drink coffee, we pour hot coffee on in a mug, and then we let it cool over time, so it's a very hot coffee. You make it, yeah, I mean, normally people make coffee hot, right? So it's a hot coffee, you pour it in a mug and you let it cool. Okay, all right. So in this scenario, over time, the temperature will drop quickly. Will drop either quickly or will drop over certain time depending on the surrounding of the area. Perhaps the surrounding has a fan or has a aircon to cool it off. That will be a different rate of cooling it down. Okay. So this temperature will slowly drop, and the temperature of the hot coffee will slowly drop until it approach room temperature, but perhaps it never exactly approach that room temperature, but it goes nearing room temperature. So the limit here, what I'm trying to say is the limit here is actually the room temperature. It never reached to that point, but it close enough to that point until we can drink it, comfortably drink it. All right. So that's, if I can put that in the analogy, that's how the limit works. Sometimes we need to quantify something, some quantity approaching a certain number, but then again, don't really take that number. You get what I mean? Like what I meant by the coffee just now. I want the hot coffee to be slowly cool off, but until it reach room temperature. But perhaps it didn't reach the room temperature. It's still okay for me to drink it. So in this context, the room temperature is the limit. Okay, so we're going to look into that in the mathematical setting. Okay, in mathematics, the limit is the value of function, value that sorry value that a function or sequence approaches as the input or index approach some value. Like I mentioned just now, um, like I mentioned just now, sorry, approach some value. Like I mentioned just now, the room temperature the room temperature that controls I mean the limit that we want for the coffee to cool off. Okay, so it is very essential in mathematics to understand and define the continuity of it. If you look at this graph behind here in figure 1, let's say the graph is in a function of fx. So when I say the graph is in a function of fx, meaning that the x is the f is sorry x is the um independent variable, independent variable, yeah, because as the x changes, the f will be changed. I'm talking about x here. The fx is actually dependent, dependent variable, where it always change when the x change. So this is the graph of fx, whatever the function is, but this is how um we imagine the graph is. Okay, so let's say in the x-axis that we have the coordinate of a here, and we have the graph that is continuous in some extent, but not continuous at one point, which is the point A here. So the limit for this function, a function f has a limit L in this particular range as x approach A, if and only if fx has both left and right limit. So we see that this function has a limit L if from the left side and from the right side has the limit. Eh? Meaning that has limit, meaning that it is quantifiable. It is a number. You didn't get infinity from left and right. So the limit still exists. So the limit of the function as x approaching a is equivalent to L, or we can look into the left side and the right side are similar. I mean the function exists and the limit exists. So we call that the limit exists and it is between um the limit L in this case. So
Yep.
so in this context, the limit um exists when left and right limit exists. Although at point x equivalent a, the function does not exist. The function is undefined at f a here, but then again the limit exists from the left side and the right side. So we call the limit exists at the value of L. Okay, let's look at the limits law. Sorry. Eh, I want to how come?